welcome to class today. How are you? Good. Okay, I'm good. Okay, so today we're going to be talking about one of my favorite movies, which is Up. I love it. Really good. But that's one of my favorite movies. Okay, first of all, we have this word problem here. Can I get a volunteer to read it? Ella, thank you.
Carl from Up attaches 6,000 balloons to his house, which weighs 20,000 pounds. If each balloon can carry 4 pounds while flying, how many balloons can Kevin pop before the house will not fly anymore?
Good job.
But Miss Shalini, there's so many words in this problem.
I know, isn't that kind of irritating?
Yeah, it is.
Okay, so that's where we're going to try and change it into an equation. So we have to deal with buzzwords.
Okay.
Okay? Good. First of all, we're going to break this problem down. So I want some of you guys to tell me what are some of the things you see in this problem.
6,000 balloons.
Good deal. So we have 6,000 balloons. Anything else?
A house.
Awesome. How much does the house weigh, Ella?
20,000 pounds.
Great. So we have a 20,000 pound house. And we know that Kevin is popping balloons and getting rid of them, right? Okay, so I know that numbers and symbols can be kind of confusing sometimes, so we'll get there eventually, but first we're going to do this problem by drawing pictures. So I'm going to draw this balloon here, and it's going to have 6,000, okay? And then that's going to represent 6,000 balloons. And I'm going to draw a little house here, and this is going to weigh 20,000 pounds. All right? Okay. And so, what is the question asking us to find? Brian, do you know?
The number of balloons?
Which number of balloons?
Oh, the number of balloons that Kevin can pop.
Right. Good. In other words, we're trying to find the number of balloons extra that Carl attached to his house, because that's the number that Kevin can pop. Okay, so to find the extra number of balloons, you want to take the total number you have minus the total number you actually need, right guys? Do you see why? Okay, good. So, but to do that, we're missing one piece of crucial information. We know how many balloons we have, but what are we missing?
How many balloons we need?
Good, okay. So I'm going to talk to you guys about one more thing in the problem. So each balloon can carry 4 pounds, right? Okay, so we know that we have 4 pounds per one balloon. Okay? And that's going to mean that our weight, because 4 pounds is our weight, divided by the number of balloons is the same as that, okay?
But why?
Why? Okay, well, just think about it. Each balloon can hold 4 pounds, right? So if you have 2 balloons, they can each hold 4 pounds, right? So it'll be 8 pounds total. And if you have 8 pounds on top and 2 balloons on bottom, it's still the same ratio because you have 4 over 1 or 8 over 2. But either way, it's always going to equal 4, right? So do you see that? Does that make sense?
Yeah.
Okay, good. Alright, so the next thing we're going to do is try and find the number of balloons we actually need to hold up the house, right? So the house will fly. So remember what I told you here about the weight divided by the number of balloons being 4? Okay, well in this case, our weight is our house, right? Which is 20,000 pounds. So let's draw our house up here. And that's going to be 20,000 pounds. And that divided by our number of balloons is going to equal 4, right? Okay, so we want to get the balloons alone, and we also want to get them on top, because this equal sign basically means that the 2 values on either side are the same. So we want to get the balloon by itself so that we know what value it is. So what is the first thing we should do?
Multiply by the number of balloons.
Exactly, because that'll get it on top and not on bottom, because it's the opposite of division. So we multiply by our mystery number of balloons here. Okay, and then the balloons on top and the balloons on bottom are going to cancel out, right? Okay, so then you're just left with your giant house equals 4 times the number of balloons we need, right? So, Brian, what's the next thing we do?
We get rid of the 4.
Okay, Ella, do you know how to do that?
Would you divide by 4?
Exactly, because right now we're multiplying. Good, exactly. I'm glad you remember things that I've taught you. Alright, so now we just have these 4s, the one on the top cancels out with the one on the bottom. So we just have our 20,000 pound house divided by 4 equals our number of balloons, right? So we have 20,000 divided by 4. Does anybody know what that equals?
5,000?
5,000. Good. So now we have 5,000 equals the number of balloons we need, right? So now that we have the number of balloons we need, we can move on to find the number of extra balloons we have, right? Does anybody want to tell me how we're going to do that?
Total minus the balloons you need.
Exactly. So what's our total?
6,000.
So we have this like picture of a balloon with 6,000. And then what do we do, Brian?
Subtract 5,000?
Okay, good, exactly. So then you subtract 5,000 balloons, and that's going to give you
1,000.
1,000, Brian, because it's not all of you know the answer, that's really great. So 1,000, okay, and so that is the number of balloons we need. And look, we solved that without using any words, just pictures, okay? And basically, that's how you turn a word problem into an equation, except in an equation, you just use numbers and random letters, but people a lot of times use X, but X is like exactly the same as using a balloon with the number sign inside. So that's all it is, using numbers and pictures or symbols like X to represent what you have in the word problem, and that way you can solve it without all the words getting in the way. Make sense, everybody?
So much
Okay.
easier.
Yeah, isn't that great? Okay, I'm glad you liked it. So now we're going to move on and we're going to write our own word problem, and then we're going to use symbols and numbers to solve it. Sound good?
Yay!